Good morning, GLA middle schoolers. Today's date is Monday, May 18th. It is 2020, and I am freaking excited to have you guys back with us again. Welcome back is the first thing that I want to say. It's been, a whole weekend since Thursday since we had our last science lesson, and I'm very excited to jump right back into these experiments where we left off, picking up at experiment number 2, and excited to see who it might be this time around who sends me pictures and videos of them doing these experiments at home. The first thing that I got to say to you guys is a shout out to those people who did their experiment on Thursday. I got so many pictures and videos of students and even their parents, which we're going to say in a second, making oobleck at home, that it just made my day on Thursday. It was so much fun getting those videos from all you guys. And I got quite a lot of them. I got not just this one from Aaliyah, and not just this one from her brother Ali, and not just this one from Janaya, or this one from Layla, or this one from Cadence, or this one from, who is this, Jamila, or a video from JL. I got all 7 of these. Plus, I got some awesome cameos from little brothers. That's Cadence's little brother Philip up here. And I even got a science experiment video from Ali and Aaliyah's grandmother making oobleck over here, playing with some oobleck. It was super fun, guys, on Thursdays to get all these videos in, and it made me excited to see that even though we're not all in the same classroom together, everyone is able to do science and try something new on their own time, on their own terms, in the comfort of their own home. And some of you guys, like JL over here, even really took it extra. You added a whole bunch more ingredients than we probably would be able to in class. And I'm glad to see that people are enjoying this and learning so much on their own time. So shout out to all of you guys. I do actually want to pull up a couple quick videos, ones that I especially enjoyed. The first one that I want to show you is this one right here. This is from Layla and her mom showing oobleck. They got Miss Brown. You got the effect to show very clearly. Check this out, folks.
Okay, I got it in my hand. Look, come on, let's do it at the same time. Let it go. But look, it looked like it's liquid, right? But it's not. This is crazy.
It's very cool watching how clear that one shows the effect of the whole liquid solid thing that the oobleck does, because it is a non-Newtonian fluid. I really enjoyed that video, and hey, we even, as I said, we got Grandmother Reese in a video here asking if the school would pay for the manicure of hers that the oobleck was messing up. Check it out.
This is messing up my manicure. The CPS or the school, is it going to pay for my manicure? Please answer. Thank you.
Sorry, I can't get a definite answer on that one. I don't think we have. I haven't heard anything about, manicure insurance policy of one way or another. I really enjoyed seeing everyone make these videos, though. And because I've had so much fun with this, and we're getting to the end of the year, I wanted to find some kind of way to make these science experiments even a little bit more special than they are. So, I have a deal for you guys to propose. I have a promise that I'm going to offer, to make. How should I put this? And it is this. The summer's coming up, and it's getting really warm outside. And as you guys know, Mr. Manta, I've got some pretty long hair, and I've been growing my hair for a long time now. It's been almost 3 years since I got my last haircut, and I'm just starting to get kind of sick of it and wonder if maybe it's the time that I trim that hair a little bit. And I know that a few of you have joked with me throughout the years saying, hey, Mr. Manta, I'm going to cut your hair one way or another. And so I want to make a deal with you guys that if I get pictures or videos of 15 different GLA middle school students doing at least one of our at-home chemistry experiments, I will shave my head. I am not joking about this. I am completely serious in this proposal. That's how badly I want to see you guys trying your experiments at home. So far, I have gotten 7 different students who have completed the oobleck experiment at home. Well, we have 3 more experiments to go. We're already almost halfway there. And if I get 15 of you to complete some of these at-home experiments, send me a picture or video as proof, then yes, I will actually shave my head. And maybe we can do a wacky, goofy end-of-the-year Zoom meeting where I can show off my, I don't know if I'm going to shave it all the way bald, but buzz cut super short hair, and I'll make a fun video out of it. This is a real offer. I'm not playing around. Yes, I take my job this seriously, and yes, I feel that passionately about you guys, wanting you guys to do these science experiments. So, this is a proposal on the table. These 7 have already done their part. If your name is not on this list, well, you had better get your act together. We have 3 more experiments for you to try. Which one are you going to do? Alright, so if you want to see this guy lose all that glorious wig on top, then you know what to do at this point. And the materials that you need, our final reminder, are right here. Today we are knocking out experiment number 2, and we'll do experiments 3 and 4 over these next couple of days. Alright, now that that's on the table, I also want to give shout-outs for some answers that I got to last week's classwork question. At the end of the lesson yesterday, I asked you to tell me, imagine that you are a material scientist, and you invent a new material that can change between solid, liquid, and gas instantly. What's one way this might be useful to people's lives? And the examples that I got for answers, so a lot of them were good, but a few of them were exceptional, and I had to show them off. For example, Jaira right here said it might be good for dehydration and fixing wounds. The idea that you could, like, if someone got an open wound in their skin, you could dress it with something that could then turn solid. It can help heal their wound. That's an awesome idea. I would never think of that. Arthur over here said it could help people. It could help because because if there's a fire, then you could turn it to a liquid. I would never think of that. You could just have something that could put out a fire on hand all the time. Michaela said a reusable balloon. So on birthdays, people can use the same balloons instead of wasting money. That's a great idea. It would also create less trash going into the landfills all around the world. We had Sinclair saying it's useful because if somebody has something but is afraid of it spilling, it's a liquid, it can convert to a solid so it doesn't get messy. That's awesome. That'd be a total advantage of this kind of substance. We had Diallo in 6th grade saying it might be useful because we could use it as body armor for police. So it's like a liquid that we could use, but then when things like a bullet tries to hit it, it would harden and then go back to its original state. That would make for probably much more flexible and wearable body armor than what the police currently use. And the last idea that I also enjoyed was you can use liquids and solids to pull pranks on your friends. And who is this? None other than Jihad in 6th grade. I enjoyed all these answers. They were very creative. We'll have another question like this at the end of today's one, and I want to see if we can get some equally creative answers again. All right, finally, we've gotten to today's do now. Sorry for taking so long. We'll make it quick from here. We do have 10 questions again this time around because we were reviewing leading up to the test. Go ahead and label today's lesson at the top of your notebook, pause the video, and answer these 5 first do now questions now. Okay, I'm now assuming that you've done this. Here are numbers 6 through 10. Pause the video and answer these ones again now. Alright, I'm now assuming that you've done that. These questions are highlighting solutions. You're about to see why for our invisible ink experiment. Alright, let's see some answers quickly. Number 1, this is the stuff we talked about in our Black video. The 3 main states of matter are solid, liquid, and gas. You've got to know that. Number 2, what kind of matter takes the shape of its container? Well, that will be liquid. If you pour liquid water into a square glass, then the liquid itself becomes a square. That's why it's a liquid. Number 3, what kind of matter has no definite shape or volume? Well, that would be gas. Gas just expands to fill up however much space it has. Number 4, what kind of matter holds its shape no matter what container you put it in? Well, that's a solid. And number 5, oobleck is an example of a non-Newtonian fluid. That's that word we were looking for that we heard a bunch on Thursday. Because it changes its state based on how much you stress it. Not based on hot and cold, but based on if you're pushing it versus letting it kind of relax. It goes solid and liquid. Our next 5 questions are right here. Ebony pours salt into water to make salt water. In this example, we call the salt the solute. Ah, yes, remember these words are coming back. The salt here would be the solute, like you're seeing in the animation up here. The number 7 in this example, we call the water the solvent. And number 8 in this example, we call the salt water. She makes the solution. Those are those 3 words we need to know. Number 9, a lot of salt can dissolve in only a little bit of water. This means that salt is very soluble. That's the word that we used. Things like salt are very soluble. We saw examples showing that sand is not very soluble at all. And number 10, eventually, Ebony realizes that she can't dissolve any more salt in the salt water. It just sinks to the bottom. This means her solution is saturated. Saturated means you can't dissolve anything more into it. It has hit its limit. All right. Hopefully you got 10 out of 10 on those do not questions. But hey, if you were missing some of these ones, well, today, by doing our invisible ink experiment, we're going to be reviewing all the stuff we learned about solutions. All right. To refresh you quickly before we hop into the experiment, we saw these words earlier when we first talked about solutions and this little animation of the salt water being made. We learned anytime you dissolve one thing into another, we have words for those things. The thing that you're doing that's getting dissolved is always called the solute. The liquid, usually that it's being dissolved in, is called the solvent. And the mixture that you ultimately make is called a solution. It's a solution because the particles of the solute are being perfectly evenly spread out. They're not clumping together, they're dissolving 100%. And we learned this little trick that you should probably write down in your notebooks right now, even if you already did before, which is that you dissolve the solute in the solvent to make the solution. If you get that in your head, then hey, you're going to get probably 3 out of 3 on these questions on the test on Thursday. Alright, we also did an online lab where you guys got to mess with this simulation a while back, if you remember this, where you would pour drink mix and other types of chemicals into the water down here, and we learned this little word at the bottom. I can't draw red on red, I guess, which is saturated, right? Saturated means the solution has the maximum amount of solute in it. It can't take any more, and if you try to add more drink mix in it, you can see down here, it's just like it kind of gathers at the bottom instead. Those are some of the vocabulary we learned about solutions and how they work. So, you're probably thinking this at this point. Enough talking about solutions. Can we make one already? It's like all of you guys, I bet. Well, ladies and gents, today's experiment will be invisible ink. And we'll be making invisible ink because it is a solution. Let's pull up the video. Hey everyone, we are prepped, we've reviewed a little bit, and we are ready to get started with experiment number 2 of our chemistry finale. Today, we are making some invisible ink. We're going to get a chance to write some secret messages, ones that you can't even tell anything's written on the paper until you reveal it, and we're going to do so by creating a solution. Now, all of you guys better know what that means by this point. We're going to be mixing a solid and dissolving it into a liquid to make a solution, and that's going to make our invisible ink. To get started today, making invisible ink is actually pretty easy. You just need a few basic things. One, you need some paper to write on. So right here I just have some note cards. You can use note cards because they're convenient, or regular paper works just fine as well. I'm going to take out, let's see, 1, 2, 3 of them. You need glass where you're going to make your invisible ink in itself, and a spoon to stir things with. You're going to need some water. You're going to need what's going to become kind of our pen for today, which is some cotton swabs or Q-tips. And lastly, you're going to need the key ingredient in our invisible ink, which is our favorite household chemical, baking soda. Maybe tied with vinegar for our favorite household chemical. And of course, you're always going to need a good workspace, and when we get to the part where we're revealing our messages, supervision of someone 18 years old or older. I got that already because, hey, that's me. But for you, good student, you cannot be doing this final part of this experiment alone, not without adult supervision. Alright, so let's get started. The way this is going to work is that we're going to make our invisible ink in this cup itself, and all the mixture is going to be is a combination of water and baking soda. Pretty much equal parts for the two of them. So all I'm going to do is to take about a spoonful of water. Ooh, that's maybe a little bit too much. And about a spoonful of our baking soda. Boom. And mix those two guys together. Now, the thing that I'm creating here, there's no chemical reactions going on yet, but instead what I am making is a solution. Since you folks have been paying attention and we just recapped in the PowerPoint, you should be able to tell me, think in your head exactly what is the solute, what is the solvent, and what is the solution. Let me think. Well, I know that I mixed the solute into the solvent to make the solution. So our solute was baking soda, our solvent was water, and our solution now is some invisible ink. You can go ahead and get it mixed up. It should look like kind of a foggy white color, kind of like that. And once you're done with that, you can set aside the spoon, and now we have our ink vat, like in the olden days, that we can use to write out our messages. Now, I'm going to take the first card. We're going to have 3 different methods at the end of revealing our invisible ink. And so I want to make 3 different note cards and show you guys one method for each of them. So for the first one, the method that we're going to have to use to reveal it, you need quite a good bit of baking soda and quite a... You gotta like really saturate the Q-tip more or less is what I'm telling you. So I'm going to write an invisible message on this note card by taking some baking soda, some invisible ink on my Q-tip here, and writing out my message. What's a good secret message? What if I just wrote... Alright. And once it dries, it is almost impossible to see that any message is written on here, let alone actually read what that message might be. If you just saw that lying around, you might just think it was a note card. Now I'm going to flip around the Q-tip to the other end for my other two messages, because I don't need to get quite so much baking soda on there, because the other two methods work a little bit better so far from what I've been trying out today. And I'm going to write two more messages. Let's see, this first one we'll say, and our last one, what can we put on it? I don't even need to refill my Q-tip here. It works pretty well, this last part. And just like that, I have now written out not one or two, but three invisible messages. See, these ones are really good. You can't even tell that anything's written on these ones. And now, I'm going to take just a quick second for those to dry, and we're going to get a chance to actually reveal what it is that was written on each of these. So, this first one I had to really saturate, because the first method that we're using to reveal what was written on it is the grape juice method. Now, I included this in the things to purchase for today, so you should have on hand some red grape juice, but I've been told you can also use other kinds of acidic and colorful juices. So I've been told like blueberry juice works okay if that's a thing. Parents, maybe red wine works. I don't know. Feel free to try it at home. But what I'm going to do here is use my grape juice as an indicator. That means I'm going to be able to wipe the grape juice across my card, and it's going to change a different color anywhere where I have drawn with my Q-tip some of that invisible ink. So I got some grape juice in a cup. And you could use a Q-tip again to do this. Like I could dip a Q-tip in here and then swab it back and forth across the card to reveal what's written. But instead, what I did find instead was a paintbrush. And this works a little bit better from what I've tried earlier today. So I'm going to dip my paintbrush in here and then just draw it across, draw it straight across the card. Let's see. And whereas you could just barely see the message before, if you use enough baking soda in your solution, and I was probably a little bit light on it again this time, now the places where I had drawn over are showing up extra dark. And you can see the message that I had written, which was, shh, shh, it's a secret. Alright, so there was method number one, the grape juice method, which of the ones that I've been trying today, I would say doesn't work quite as well as the other two methods, but it is a very cool chemical reaction that happens between the grape juice and the baking soda to reveal it. And it's probably the most family-friendly, the safest one on hand. Our other two methods are a little bit more challenging because they involve heat. So, let's see. For method number two, I'm going to take another one of my invisible ink message cards, and this time I'm going to need a lighter. Like I said before, you are not trying this at home without parent supervision, someone 18 years or older. Just to be extra special sure, I'm also going to take my safety goggles and put those on today. And basically what needs to happen is, in order for the baking soda that I've drawn on here to show up, I need to heat up that area of the card enough to cause a different chemical reaction that reveals the baking soda. So what I'm going to do is I'm going to kind of take the card and lay it flat like this, and then I'm going to strike my lighter to get a flame, and hold it underneath the card, and move it closer and closer until I can start to see the card browning a little bit from the heat from the flame. Now you never ever ever want to actually touch the flame to the card because then it will catch on fire. You probably have something like a towel or a pot to put on top of it if you need to on hand so that you can put out that fire if you need one. But I never want to actually touch the flame to the card. I don't want to start any kinds of fires. I'm just going to get it a little bit close to the underside of that card, and if you watch closely you will start to see your invisible ink message showing up. I'm going to wave the light all around different parts of the card. You can probably see on the video there. It's starting to show up. Dun, 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 dun. And this method, I have to say, it works really well. It is a little dangerous, but these messages do show up very bright and clear for us to see. And you can see on this card that was blank before, it now says secret. There's my secret message. You probably have more interesting ones to write to your friends if you're in 5th or 6th grade. Lastly, I do have one more card. And for this one, we're going to try my favorite, my #1 favorite reveal method of all. And in order to do that, I'm going to need you guys to come with me right over to over here to, what's it going to be? Ta-da! The ironing board. Right here I have my mom's old iron. Mom, how long have you had this for?
Mrs. Schwab gave it to us, I believe.
Oh, our neighbor gave it to us some years
Yes,
ago.
'cause we got that.
And I've had this iron on and heating up. The way that you can test out, by the way, if something is hot, the safe way to do it is to never touch the thing that you think might be hot, but to use the back of your hand. So let me see. Oof. Yep, okay, that iron is pretty hot. And I'm going to, this time, instead of using a lighter, I'm going to use the heat from this iron to actually reveal what's written on the card. So as you can see here, I have the iron turned up all the way. I've been testing it all day, and it looks like you have to have it pretty hot in order for it to work. But Mom and Dad, we don't need any steam this time, so it's just a plain, dry, hot iron. I'm going to take my mystery card that I have my message written down on, and I'm going to just iron it as if I was ironing a shirt. Alright, and it will take just a minute if your iron is actually hot enough for it to be revealed. I would say start out by having the iron on a pretty low setting, and then gradually increase the heat until you can start to be able to make out the message that you have written. Dun, 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 dun. And that one is working pretty quickly. And just like that, I have my secret message revealed. I'll carefully pull it off of here. And the message said, "Don't tell. Shh, it's a secret." Alright, ladies and gents, those are the 3 methods that we have for revealing our invisible ink. And the one method that we have for actually making invisible. Hold on. Wait a second. I just found over here this... Mom, did you put this piece of paper here?
No,
No,
I've
you-
never seen that.
Interesting. I just found this other piece of paper that was sitting here. I wonder if maybe there's something written on it. Well, let's find out. Wow, guys. I have to say, I don't know who it was that left this paper lying around that wrote this message on it, but I can say I totally agree. Alright, folks, that's all we got for you today. Back to the slides. Wow, what a great message. Whatever mystery caper person must have been leaving those around. Who knows? Maybe it's Miss Mathis or Miss Merrick or somebody has good taste in their classes, though Purdue is king. Sorry, UT. Sorry, Georgia Tech. Alright, I want to recap everything that we just saw because that was a lot of information. First of all, the main key point that I want you guys to take away from today's lesson is just a review of solutions, solutes, and solvents and all that. This is the idea that invisible ink, if you want to make invisible ink, I mean, there's lots of ways to do it, but the way that I showed you today is to make a solution of water and baking soda. In this case, the baking soda was our solute, the water was our solvent, and the invisible ink that we mixed together is therefore a solution of those 2 things put together. If you're good to go on that terminology, then that certainly bodes well for your upcoming test. Again, we have a test on Thursday. At this point, we're going to pause the video. It's been a while since I've had you actually do any work on your own in your notebook, so here. Pause the video and answer class for question 1. Is dissolving baking soda in water a physical change or a chemical change? And how do you know? Make sure you answer both parts of it. Pause this video and answer that question now. Alright, we're going to pick up and move along from there, because we want to talk about the cool parts of what just happened, right? First of all, when I say invisible ink, the part that sounds like it's going to be amazing right there is this idea that I have ink which is invisible. You might be wondering, how can the ink be invisible when it's first written on the paper when it doesn't show up? Well, actually, that part's not really very special. All that's going on when I mix together water and baking soda and write it on a white piece of paper is that the water is clear, the baking soda is white, and you can't see it on white paper. It just doesn't show up. It's like trying to draw on a white piece of paper with a white crayon almost. That's why it's invisible. What's really cool is not how it's invisible, but how it turns visible. So the first method that we saw for revealing your invisible ink was to use grape juice. When we use grape juice, that's one of the fun science parts of this experiment. Really, that's what's cool about it. Grape juice has this property, and we're not going to, this is advanced stuff, this is high school stuff, so acids and bases won't be on your guys' test, but I have to try to explain it as best as I can right now, so listen up as best you can. Grape juice has this property, it's a chemical property, it's called being acidic. It's very mildly acidic. It's totally safe to drink, but lots of liquids that are around you have this thing which called being acidic. They are acids. There's really strong acids like hydrochloric acid, which is dangerous, but a lot of things are very faintly acidic, like even Coca-Cola or lemonade or grape juice are acidic. There's also this thing called, in chemistry, called being basic, and no, it's not like when kids call each other basic as a joke. Basic is like the opposite of being acidic in chemistry, and you'll learn the details of it in high school chemistry, and you'll be talking about acids and bases all day. But basically, if it's the opposite of being of acidic, right? Grape juice is acidic, baking soda is basic, and the rule in chemistry is that when something that's acidic touches something that's basic, there's a chemical reaction, always. And so when you're looking at the card right here, most of this just kind of like purple space is space where I just painted grape juice onto a plain white piece of paper, right? Nothing special happened. But the spots where I had previously dragged my Q-tip along and painted on with baking soda and water had this extra chemical reaction happening that's causing it to show up this different color. So this almost like bluish, grayish color that you see is a combination of baking soda and grape juice having a chemical reaction and producing a new substance that is this color. We're not going to go into what that substance is, but just know that on all these spaces, there's a chemical reaction happening, producing this blue color, whereas in all the other spaces, there isn't. And that's why this invisible ink shows up when you wipe the paper with grape juice. Now, how about the other methods that we saw? We saw that you can also reveal your invisible ink by heating up the paper to just the right temperature. I did that with a lighter first, and then I did that with an iron afterwards. Why does heat turn the invisible ink visible? Well, I looked around online for a good answer for this, because this is actually a pretty complex question. I'm not able to tell you guys the answer for sure, I just know that it works. But the best answer I saw was this one. Again, this is kind of a high school level answer, so it's a little bit tough to understand, but give it a shot. These people online are saying that how this works is that writing a secret message in baking soda solution slightly disrupts the fibers in the paper. So paper and a lot of plants are made out of this stuff called cellulose. And they're saying that if you wipe baking soda solution onto something that's made out of cellulose, it tears up the fibers and damages the surface a little bit. So you're kind of damaging the paper anywhere where you draw over it with baking soda solution, with invisible ink. Then they're saying when heat is applied, the shorter exposed ends of the fibers darken and burn before the undamaged sections of the paper. So at least the way that these guys are claiming it works, and this is an explanation that I found online, I would like to do more research, I would like to see some of you guys do some more research on how this really works, is that they're saying by rubbing a baking soda solution onto just these certain parts of the paper, I'm actually damaging the paper a little bit. So then when I hold the heat, the lighter or the iron up to it, the message in that damaged part of the paper shows up and turns brown sooner than all the other spaces turn brown and burn. It makes it burn easier in those spots where I hold it up to the heat. It's an interesting hypothesis. I think there's some more testing that one could do to find out if that's really the way it works, but I'm going to trust them about that for now. I thought that was pretty cool. Again, this as well as this are both kind of high school level stuff. The details are optional, but I had to show you guys because I find it so cool. All right, at this point, we're going to pause to answer classroom question 2. Like I said, we have another chance to do an application question here. I want to ask you, what is one situation in which you might need to use invisible ink to write someone a secret message? I didn't have any really good examples. I just wrote secret and shit on my cards, and then some mysterious person wrote Purdue is king, and I thought that was pretty cool. But what's a case where you might need to write something in invisible ink? Have it be funny, silly, whatever it might be. Just give me a cool example. Pause the video and answer this question now. Alright, I'm assuming you have now done that because we are moving on to the independent practice. That's right, we're wrapping it up. I know the video got long today, but let's knock this out. We got our first 5, we are going to have 10 independent practice questions as usual, so number your paper 1 through 10. Here is 1 through 5. Pause the video and answer these 5 questions now. Alright, moving right along. Numbers 6 through 10 are here. Pause the video and answer 6 through 10 now. Alright, and moving right along to see our answers. Numbers 1 through 5, here we go. Most of the time, if you mix 2 substances, do you get a mixture or a new substance? We learned this all the way back from Crash Course in our first video about solutions. We learned that we get a mixture. New substances being created is actually pretty rare. Chemical reactions don't happen that often. Mostly when you mix two things in a day-to-day life, you just get a mixture. Number 2, a solution, is the word we're talking about today, is a special kind of mixture where the particles are evenly distributed. Number 3, making a solution is an example of a physical change to matter, not a chemical change, because there's no new substance being made when you make the solution. Number 4, a lot of baking soda can dissolve in a little bit of water. This means that baking soda is highly soluble. That's that word that means you can dissolve it. 5, if you add too much baking soda to your water, it will sink to the bottom because the solution is saturated. That's what happens when you try to add too much solute. And here are the answers for 6 through 10. 6, when baking soda touches grape juice, a chemical reaction happens. Does this mean a new substance was created? Yes, because that's what it means for a chemical reaction to happen. For number 7, we're starting to preview next day's experiment. Name as many of the 6 signs of a chemical change as you can remember. Well, here are the 6. Number 1 is that it can't be undone. 2 is that there are changing properties, like it changes color or it changes the texture. 3 is that it makes smells. 4 is that it releases light. 5 is that it fizzes or it makes gases. And 6 is that it gives off or takes in heat. I would say count yourself correct for that one if you got at least 2. And then go ahead and add the other whatever ones you were missing to your notebook now so you have that to study off of later. Number 8, Paula mixes lemonade powder into water to make lemonade. In this example, what is the solvent? Well, the solvent is the thing that's being mixed into, if that makes sense. So here the solvent is water. What is the solution? Well, here that's going to be the lemonade that she makes at the end. And what is the solute? Well, that's going to be the lemonade powder that you mixed into it. All right. Go ahead, as always, star those ones you got right, fix the answers you got wrong, and tell me which are which in the independent, in the classwork form. And ladies and gents, that's all we had for today. It is now exit ticket time. Go ahead, go knock out that exit ticket. And I wanted to mention, so today's cool thing, right? I listened to quite a bit of music. I was thinking about that time in Purdue earlier this year when I watched School of Rock. I listen to a lot of music. I like music a lot, and I haven't shared a lot of my music with you guys. So I'm going to do a few songs coming up for the next few Today's Cool Thingses. And since I was thinking about rock and roll and having to cut my hair, it made me think about this song called War Pigs by a band called Black Sabbath. And it is a rock song if you have ever heard one. I'm going to link it in today's for today's cool thing. If you just want to listen to a kick butt song and rock out and have a good time, check this one out. I would highly recommend it. Black Sabbath is a fantastic band. It's a video all the way from 1970, and man, even then they were rocking out. All right, that is all we got for today, folks. Take care and talk to you tomorrow. Hopefully, I'll be seeing quite a few of you and talking to your parents before then, because you'll be sending me videos of you making invisible ink messages. All right, take care.